Hi, it's me, Dr. Maya Dume. I'm just showing you a video about this chapter, incoming chapter we are doing, which is solutions. So you have some idea what we are looking and what I'm expecting in the chapter. So let's look at the chapter, and then you know what is my expectation, and then it'll help you a little bit to understand the chapter as well. So let's look back the chapter. Solutions. Um, So, basic solution has two parts, solute and a solvent. Think about simple sugar solution. You take sugar, dissolve in water, sugar becomes solute, water becomes a solvent, or you mix together, it becomes a solution. And then, so you have these tendency, the entropy, and then always you have to keep in mind, in order for anything to become dissolved in another solution, uh, so basically, dissolving, you have solute, solvent, solution. Solute, solute interaction should break. Solvent, solvent interaction should break and make a new solute, solvent interactions. This solute, solvent interaction should be higher than solute, solute or solvent, solvent. Then only you will get a solution. If not, you will not get a solution. That means it's not soluble in water. So always solid things soluble on in the like polar solute dissolving on the polar solvent, non-polar goes to the non-polar solute. So this is the this diagram shows you a little bit of energetic of solute formation. I gave you a short note for this chapter which is very detailed about this concept, because this is important for you to understand. Since I'm here, I'll just show you some closely what I'm expecting there. I mean, what is the meaning of it? So you see here, first step, solvent. You have solute in purple color, solvent in green color. First, it's like a thing about sodium chloride and water. This is sodium chloride. This is water. That's it. So in order for the first solute break, that's where solute separate. Still, a solvent hasn't separated. So the separation means breakdown. Always breakdown is endothermic. You need to give energy from the outside for the bond breaking. Bond breaking is endothermic. That's what I make the arrow upward. Arrow upward means it is endothermic. Similarly, solvent, think about its water, should break. Again, endothermic. So you have separated solvent, separated solute. Mixing, making a new bond. Always bond forming, exothermic, releasing energy. That's why it goes down. Net effect is exothermic because exothermic is higher in bond forming. It releases higher energy than bond breaking. Net effect, it releases energy. The same thing I explained here. Solute in again in red color, solvent in light green color, breaking, endothermic, releasing it less energy release when forming the solution. So the net effect is endo. And then we talk about solubility, saturated solution, unsaturated solution. Henry's law. Okay, this is another thing important. And then okay, if you think about the solubility, okay, if you think about the solubility of gases, solubility of solids increase with increasing temperature, but solubility of gases decrease with increasing temperatures. That's different. Um, and then you're getting your first equation, Henry's law, solubility of gas, Henry's law constant, partial pressure. Higher the partial pressure of a gas above the liquid, higher the solubility it is. And then we are moving to the important concepts, which is molarity, number of moles in a liter of solvent, solution, sorry, molality, amount of solute in moles in mass of a solvent, mole fraction, mole percent, parts by mass, percent by mass, ppm, ppb. Those things very important calculations. So if you look at molarity, molarity very commonly used in chemistry. If you think about molarity, so the molarity is, you can write M, number of moles in liters of solution. So basically volume. So M, number of moles, N, volume, M equals N divided by V. This is molarity also represented as concentration, C, N divided by V. Always you can find the molarity dividing number of moles by volume. Very important. Molality is one, right? Molality. Molality is moles of solute divided by kilogram of solvent. That is molality. And then we talk about mole fraction is important. ppm, ppb is it's good, it's important too, but mole fraction is another one, which is x, which is moles of substance. If you have two substances in a mixture, which is substance A and B, moles of substance A, total moles of substance, um, so basically A divided by number of moles of A divided by number of moles of A plus B. So that is the mole fraction. Example, if you say I have a class of 10 students, 5 boys, 5 girls. Fraction of girls is 50%, 5, 0.5, and percentage wise it's 50%, something like that. So that is some okay, I want to take this question, which is question number 13.4, and show you how to do it. You can also see, you can see clearly the question, but I'm working on question number 13.4. I'll explain you how to do it. So in 13.4, I'm talking, let's do the how do you do it. Let me read the question. You prepare a solution by dissolving 17.2 grams of ethylene glycol in 0.5 kilograms of water. The final volume is 515 milliliters for this solution. Calculate A, molarity, B, molality, C, percent by mass, mole fraction, mole percent. How do you do it? First, we have to do molarity. What is the definition of molarity? Number of moles by volume. Here, how do you find the number of moles of ethylene glycol? I know the mass, right? Or how to calculate the number of moles? How do you calculate the number of moles given mass divided by molar mass? What is given mass? It's in the question. 17.2 grams. What is molar mass of ethylene glycol? C2H6O2. How to find the molar mass? Carbon 2. Carbon is, how do you find the mass of carbon? You look at the carbon in the periodic table. It's 12.01. 12.01 into 2 plus 6 plus oxygen is 16 into 2. So you add 24 plus 6 plus 32. You get 30, 62. Right? I'm getting the molar mass as 62 moles per gram. So that is the that is my molar mass. So to find the number of moles, I divide by 62, 17.2 divided by 62. So I'm getting 0.277 moles, right? I get 0.277 moles, And then volume is, what is the volume? Volume is 515 final volume, but it's you have to convert into liters, milliliters to liters. 515 milliliters. You know always 1 liter is 1000 milliliters. Milliliter cancel, and then you get 0.515 liters. So my molarity is 0.277 moles divided by 0.515 liters, and then I getting my answer as 0.538. That is my molality. Molarity, always number of moles divided by volume give you the molarity. And also I have find the molality, amount of solute, which is the moles. We already found the moles, divide by the mass. You get the molality, and then the percent by mass, mass solute, mass solution into 100. Mole fraction. Mole fraction, I'm going to show you. Mole fraction is, we already know, in order to find the mole fraction, how many moles of ethylene glycol we have. How do we find the moles of water? Because in the mixture you have ethylene glycol and plus water. So you know ethylene glycol you have 0.277 moles we just found, and then water mass is 0.5, number of moles of NH2O, number of moles, let me write it, number of moles of water 0.5 kilograms, we convert into grams, kilograms, 1 kg is 1000 grams, so it's going to be 1, 2, 3, 500 grams. You divide by 18, right? Then you see you get 27.77 moles, and then that many moles you have, and then mole fraction x water, number of moles of water, which is 0.277 divided by 0.277 plus water. And I'm getting as 9.89 into 10 to the power negative 3. So this is how you find the mole fraction. And then we talk about little bit, so towards the end, we talk about colligative properties, vapor pressure lowering, boiling point elevation, freezing point depression, Raoult's law. For these calculations, you see, we talk about, okay, freezing point depression. There, everyone we have an equation. So in the exam you can bring a little formula sheet. So why don't you write the formula, and then if I ask you, so you know, okay, this is freezing point depression, this is the equation, so I can do it. So like that, you can have a little trick for that. Raoult's law, a little bit important. Freezing point depression, so delta TF, M, KF, which is M is molality, KF is freezing point depression constant. And then we go to the osmosis, and after osmosis, Van der Waals factor. Van der Waals factor is something, okay, how many particles, when you dissolve an ionic solid in water, how many particles it dissolve, like sodium chloride, sodium positive ion, chloride negative ion, 2 particles, a magnesium sulfate, Mg2 plus, SO4 2 minus, 2 particles. Van der Waals factor. And then red blood cells. If you put in the isoosmotic solution, nothing going to happen. Hyperosmotic water will go out from the red blood cell, so it's going to shrink. If you put a hypo, outside water can come, so always red blood cell should maintain isoosmotic solution. So this is about chapter 13. I think you have idea what you need to look at chapter 13. Thank you.